Alrighty, 7:35. We'll go ahead and get started here. So tonight's little fun is going to be soldering together a 1-bit full adder prototype. This is going to be a breadboard friendly prototype, and recently I just released this really nice little Boolean bits prototype boards. And there's enough items on this breakout board, a single one, which is selling through Tindy, to build a full bit adder. I've got one right here where I've actually soldered on the headers and put it on a breadboard. And so you can actually go through and use this to build up a 1-bit adder. Full adder, but it does take up quite a bit of space on your breadboard in order to build up one full bit adder, or even if you wanted to do a 4-bit full adder. So I'm really interested in doing designs in which we can understand modern day computing and logic blocks. So I really wanted to create some of these breakout boards so I can experiment with them, prototype on breadboard or whatever it may be in different architectures. So this is actually a diagram of a standard 1-bit full adder. Let's slide this over a little bit. So what we're looking at is two XOR gates, two AND gates, and an OR gate. And so what I've done is replicated this with single gate logic. And so what we've got are these prototypes that I just got. I like to get different colored of the PCBs for prototyping and such. I kind of like these orange. Or they're listed as yellow, but they're much more orange to me. So that's really what I'm going to be using, is one of these orange PCBs today to do the assembly and testing. Now ideally what you would want to do is get 4 of these together, or 8 of them, and make a 4 or 8-bit full adder. And these are primarily used for binary computer systems in which they want to do mathematics. These are at the heart of every arithmetic logic unit, or ALU. And what we want to do is eventually be able to use these full bit adders to build up a very basic ALU. Now, like I said, these are just very basic designs. This particular one I've done excuse me, in EagleCAD, and I've also open sourced the files. We have a Hackaday IO account for Dave's Dev Lab, and these files have been released on the Hackaday IO as a Creative Commons CC by NC for non-commercial use. The design files, you're welcome to use them, just not for commercial usage. And so what we're going to be doing tonight is go through and solder up one of these boards. But while we solder it up, we're going to talk about a bunch of other little things like design choices and tools that we're using in order to assemble this up, and maybe a future product or two that we're looking at doing. So with that in mind, I'm going to start out with talking about the stick vise that we're going to be using right now in order to hold the PCBs that we're going to be working on. So let me move this over just a bit, switch cameras so that you can see our stick vise here. Now, I'm a big believer in the stick vise. It is just the best thing since sliced bread. This is the standard one, that Hackaday sells through their store. I believe Adafruit now sells it as well. And this allows you to take a PCB and just spring load it and hold it in place. This is really great for SMD work. It sits flat on the table and you can spin it around wherever you want to, angle that you want to work on. You can also release it. It's very easy. It has the default length of the rod allows for a very large PCB to use. Actually more space than the typical PCB that you can get through Eagle CAD or generic designs. Most of the board shops will generally give you a good price break on 100 millimeters by 100 millimeters, so the standard one will accommodate it quite easily. One thing that I do find is that with smaller boards like this particular one, I'm using it fairly close up, and when I want to do some soldering, I'll start out with this position and it works quite well, but when I turn it around this way, it actually usually pokes me because it's a little bit longer here than the table. And if I have to use it under a microscope such as this one, it'll bump up against the table or the base of the microscope quite easily. So what I've done is I've modified one of the ones that I have to actually have a shorter base. This is the one with the shorter base. I've cut it about half the length of the normal rod, and this allows me to use it fairly close up. Latch that one down and this one away, and it's fairly short, and so if I want to use it under the microscope or something else, I've got plenty of room to move it around, and when I'm soldering close up, it's not poking off the end of the table. It works out pretty good. But the best thing about this thing is if you do have a 3D printer, you can also print different holders for this and different combinations. If you do a lot of through-hole components, you can get little standoffs. There's standard standoffs to put on there and stand it up a little bit higher. So if you do want to turn it over and work on the board for through-hole parts, the standoffs make it a lot easier. So that's where we're going to start tonight, is with the stick vise, and we're going to put one of our boards in here and just have a quick look at it under the microscope. Make sure it's securely in there. Let's pull the microscope down here. And focus up. And we're going to switch cameras so that our microscope is the main one. Alright, so again, what we're looking at is two XOR gates, two AND gates, and an OR gate. We're going to let on the board, we have an A input, a B input, and we have a C input that's the carry input from the previous circuit. We also have an S for a sum and a C out, which is the carry out to the next circuit. This is a placement design from Eagle that's showing all the components that we're going to be dealing with today. Now, you'll notice that I actually have 1, 2, 3, 4, 5, 6 pins on both ends. As noted from our block diagram, we have 1, 2, 3 inputs and 2 outputs. That's an awful lot of pins just for those 5. What I've also included here is pin 1 on both ends is a your VCC input, your voltage input, and pin 6 is actually a ground on both ends. And we actually have each of the pins labeled, so this would be C input, B, and A, and this one's not used for anything. And then down here on the end, we don't have anything for this one. Excuse me. This is our carry out, nothing for this one, and then we have S for our sum. So you can see we've got a few extra pins on here. And the reason I did that was I actually wanted to use something that's actually easy to get. When you put this on a breadboard, you actually use up a lot of the pin space to plug in prototyping cable. So what I wanted to do was find a through-hole header with long pins, and of course everybody knows about Arduino stuff, so you can easily find these 6-pin headers on eBay and a lot of other places in China that have through-hole connectors and stems, so you can plug them into the breadboard easily. So my intention was to use one of these on each end, and so by going with a 6-pin header, I was able to get a very good deal on these connectors from a lot of different vendors, and it's a standard component that everybody has available, so it makes sense to go with a 6-pin header even though we aren't actually using them all. And we'll look at more of this at the end where we go through and actually solder one of these in place. So we'll put that to the side and start having a look. So every good nerd should be at home on Friday night doing electronics, and that's where we are tonight. So hope everybody's enjoying a beer and watching the video, and if you're not the type to drink, you can have some root beer or something. At least it's something with the word beer in the name. Alright, so still trying to get a little used to the camera, guys, so and remember there's about a 30-second delay on this, so sorry about switching back and forth here. What we're going to be looking at next is one of the tools that I'm using. This tool is actually a curved tip tweezers, and it's actually reverse force tweezers. These aren't very intuitive when you first start using them, but I prefer these a lot more than the regular tweezers when I'm doing SMD components. And the reason I do that is because when you're using a regular pair of tweezers, you have to squeeze it with your fingers in order to keep constant pressure on it. And when you're doing that, your muscles are tense, and it's very difficult to make very fine motor adjustments to the placement. So we're going to start out and place one component. Let's start out with these XOR gates. Let's find the components for those. We got them here. This is the 74 LVC 1G86. The 1G stands for one gate. And we're going to pull two of these out because we have two different locations. We've got one here and one here based on our block diagram. Alright. Now normally for prototyping I have a set of cut tape for parts. But when I do production with a pick and place machine or a larger volume of stuff, if I use my manual vacuum pickup tool, I'll generally get those on spools. But for prototyping, I generally like to get my components on cut tape. It makes it a little bit easier to keep things together as a kit. Now I've got my Haku soldering iron going here, and before we get started placing this, we're going to have a look at my tip here. I've got a fairly short but very precise tip set up on the soldering iron. This one works well for providing a lot of heat very close to the temperature sensor. I went ahead and calibrated this with the temperature sensor to make sure that I was reading properly, and so this tip will provide enough exactness so that I can solder together the SOC 23.5 packages as well as the 0603 packages. So this will be the first time I'm doing this with a USB webcam, so y'all have to bear with me, try to make sure I get everything straight on this, and hopefully my bald head won't reflect too much light and blind everyone. So if it is, just let me know. So we're going to start out now with some solder. Now I like to use either 6040 or 63 or 6337 solder when I'm doing prototypes. It just melts better when I'm working with it. And so I'm going to be doing these two components. So the first thing that I want to do for those two components is pick the legs that I'm going to actually solder to first to tack the device down. So that's these two pieces right here. Now what I want to find is a leg that I can solder to easily that is not a voltage pin that's tied to a ground or tied to a plane, or a ground pin that's tied to a plane. And usually you can tell right off the bat which ones are that way, and I'm going to turn it sideways so we can see. And so this one and this one are probably the best ones for us to deal with in order to do that. So I'm going to just put a little bit of solder on there on that pin on both of these. So I have enough solder on there to tack down the part. Oops. Alright, and now we're going to take the tweezers here and pick up one of our parts. And as you can see, I'm not putting any force on the tweezer. I'm simply holding it at the tip here as an example, and it's holding the part. So I don't have to put any force directly on the tweezer in order to hold my part. Now this works great because you can actually hold it and do very fine motor adjustments without putting a lot of pressure on the part. What you find is a lot of times if you're using a regular pair of tweezers and you're squeezing it very hard in order to hold the part in place and get the motion that you want, that part is going to snap right out and you'll lose it forever. It's off the side of the desk or who knows where on the floor, and it's very hard to locate. So this works out very well on this type of placement. So we're going to go ahead and put this one in place. Now I like to put it on the board first to make sure that it's sitting flush with the PCB when I pick it up. If you're unsure that if it's flush or not, you can actually hold it down and put the tip of the soldering iron on the top of it just to make sure that it's flush. You won't hurt the device. You might get a little bit of solder on the top, but the ceramic will prevent it from doing any damage. So I'm going to heat up the pad and then slide the part in place. Now, this one's a little bit crooked, so I'm going to heat it up and move it just a little bit. I'm totally OCD with my SMD components and want to make sure that it's on there pretty well. Now, this particular one is in place. However, it's in place by only one leg. And it's very, very, very easy to damage this now by bumping it, and it will twist that one leg off. So as soon as you place the first leg, you want to get a second leg somewhere that will give it a lot of dynamic support from torsion and twisting of the board, or of the part. So I'm going to go ahead and solder the second leg down, and it's not really important that it be a clean solder. And as a matter of fact, you can see on this one I've got a little leg off the top of it. We'll see how to deal with that in just a moment. So we'll go ahead and place that part, the next part. Alright, so I'm going to make sure my alignment on the part is good. Turn it around so I can place it. Again, I got it here. I'm going to put it on the PCB and make sure that it's sitting flush. Tap it down just a little bit and then slide the part into place. And again, we want to tack down this one as well. And again, we're not really concerned about the quality of that solder joint or actually either one of those solder joints, because we'll come back to those in a minute, but we just want to make sure it's in place first. So we've got two of our parts in, both of the 86. So I'm going to mark those in yellow. So now we need two of these 08s. These are the AND gates that we're going to put on board. And let's see here. Our AND gates. And we need two of those. Oops. Now, one of the things that you can see on Hackaday, there's a really good post, I'll add it into the comments, about cleanliness in the workspace. When I was first started doing electronics, I just had parts all over the place, but one of the most important things that you can really learn about doing electronics is put your parts away, or else you'll get them mixed up. So once you're done pulling out the two parts that you need on this, put it back in the bag and make sure it goes back in the correct bag. And if you're picking up something like a box of screws, or a box of leads, or a storage container of resistors, the best thing you can do is to make sure that you put them back in when you're done with them, because there are two rules on that. Either A, you're going to end up mixing up two parts and put one in the wrong bag, or sure as the world exists, you're going to knock over that box and it's all going on the floor. So just put the lid back on when you get a chance. So we've got our two parts, the 08s, which is the AND gates. So we got to identify those places on the board. So that's this component and this component. And again, we want to choose something that we can see is not a power pin or a ground pin, because those are being connected to ground planes and they'll suck a lot more heat away. So we generally want something that's a signal pin that we can solder to directly and won't take as much of heat requirement. And so let me check the focus here, make sure we got everything in focus. Looks good. And so we're going to solder those up. Now, one of the reasons I like to do it this way and go ahead and solder both of them and not all of the pads is it makes it very clear about which two components that I'm actually going to be soldering together. And so very, very good to help identify, especially if you have a lot of components to solder on. This helps you keep a track of which ones that you're actually going to be soldering next. So we're picking up the part, same as before. Make sure it's flat. Slide it in place. That one's just a little bit off. Yeah. And then we're going to tack it into place for the second leg. Now usually if you only have one leg soldered, it's quite easy to correct it, but if you go ahead and solder the second leg or more of them without checking the alignment, you usually just have to take the part off completely and start with a fresh one. So you should always check your alignment right after you place the first leg. That one looks pretty good. And we're going to go ahead and solder that one on as well. So let's mark those two down. And the last big component that we're going to be dealing with is this one, which is the 32, which is the OR gate. Let's see here. Oops, I'm going to get my glasses. And we want the OR gates here. And we just need one of those. Oops. Looks like we already got one out here. And again, putting away our parts. And we're going to put a little solder on our pin here and slide her in place. And tack it down. So now we've got all our big components. What we lack now is some resistors and some capacitors on the board. Now, of course, as some of you will know, a few years ago at a embedded Linux conference, I misspelled the word resistor multiple times in my presentation. I forgot to run spell check, so if anyone out there wants to troll me about these being resistors without the T, feel free to comment. So we've got some 0.1 microfarad caps to add, some orange LEDs, and some 220 ohm resistors. Now, the schematic that I did actually includes the value 220 ohms for these resistors. I actually changed this value in the production stuff. I'm actually using 243 ohms, and the reason I'm using that specific value instead of the standard 220 for the production stuff is I found that these particular boards I want to work at both 5 volts and 3.3 volts. And in order to get a good range on the LEDs, the 243 was a really good value to use. Now, it's not a standard value that you'll be able to get regularly, so if you are building this up yourself, the 220 ohm resistor is probably the best to use and easiest for you to get. But I do have a lot of stock of different passive values, and that one just generally worked really well for me. So we've got a total of 5 LEDs, 5 resistors, and 5 capacitors left to put on the board. Now, you're probably saying now, wait, Dave, you only put solder on 2 of these pins of each one of these devices. Well, we're going to come back to those in a minute, and I'll show you why. So just hold your horses on it. We'll get back to it. So next one is our capacitors. So we need 5 capacitors to put on this board, and as I was saying, I have a pretty good stock of passive components, and I tend to buy them on reels because it just makes sense cost wise, and plus I use them with the pick and place machine. And so sometimes I'll cut some of it off as a cut tape and use it, but I generally keep it as a big reel. So I'm just going to pull off 5 of these caps for our prototype build. Now these are 0603. These are a lot smaller than most people will work with when it comes down to building their own prototypes at home. They are pretty darn small. But in this case, I really needed the small size in order to make this breadboard friendly and to get all the components on there that I really wanted to have. So just like before, what I'm going to do is pick a non-ground pad, non-VCC pad, and what I'm going to do is go through and put a little bit of solder on each one of those pads. So we're going to start out with these 3 up here, and those are going to correlate to these 3 here. Oops, actually, so those are the LEDs and resistors. What we want is these capacitors here. This one, this one, this one, this one, and this one. Now, I generally like to have the pad I'm soldering to on the right hand side to make it easier to get to from the soldering iron. So and you can clearly see all of the ones here on the right hand side are ground pads. So I'm going to rotate this 180 degrees, and then I'm going to put a little solder on each one of these pads so I know which ones I'm soldering to. And then I'm going to pick up, here, go ahead and switch cameras here. I'm going to pick up one of the capacitors, and you can see these things are pretty darn small. These are 0603s. Now you can of course go smaller to an 0402 or an 0201, but shoot, it's pretty darn difficult to solder by hand, even with a microscope and with a lot of practice. So I'm going to go ahead and same procedure as before. I'm going to make sure it's kind of flush to the PCB. I'm going to heat up my pad and slide it in place. Now again, we're not really concerned about the quality of that solder joint right now. So we have one side of each of the 5 capacitors soldered in place, and we're going to leave them there for the moment. And so the next one we want to do is add our 5 resistors, or resistors depending on who wants to troll me this evening. Again, these are 243 ohm, and I just happen to have a couple spools of these, so they tend to work out real well. And we've got our 5 resistors. Hope everybody's enjoying the assembly process here. Take just a second to catch up on some of the questions here. So you can glue them into place, but I've never glued the parts in place, but I've never really had that much of a problem doing that, or the need to do it. As long as you have the right tools together, like for instance a good pair of tweezers and a good technique of sliding the part into place while you have just one pad heated. That works really well, but I have indeed seen a number of people that have gone through and glued the parts in place. Just anyone that has just joined and missed parts, you can actually, YouTube has a DVR function, so you can go back to the beginning of the live stream video, and in addition, I'll have the full video up on my channel later this evening, so if you want to start back again, you can. So definitely you'll be able to go through and look at it and review it if you want. So back to our resistors here. We're going to put those in place. Now this one presents a fairly interesting problem. Up here, let me switch to our schematic or placement diagram here and have a quick look. One of our problems is that our LEDs are very close to these resistors, and not only that, in order to use my rule of not using a ground pad in order to solder these in, I'd have to solder both the LED and the resistor from these middle pads, and with this tiny space and the soldering iron tip, it's very easy to heat up the wrong pad. So if you've already put down the LEDs and you try to do the resistors, most likely you're going to end up interfering with the LEDs. So it's kind of tricky on this particular assembly. So what I'll be doing is doing a little bit of a breakaway from my standard procedure of not using a ground pad on it. So we'll use the opposite end to make it a little bit easier on the LEDs. So, but we'll get back to that in just a second. Let's go ahead and go through, and of course I scattered my resistors out while I was looking around. That's not good. Got distracted, and I think I've lost some. What? Let me tell you. Now that's a problem when you take them out of the tape and you lose them that way. You have to be really careful. One of the things that I do have is some cut tape pieces that allow me to put a cut tape into a little tray. I bought these off of Tindy. It's a little tray. You can put, it's 3D printed. You can put your parts in there and pick them out. But you can see these are pretty darn small, and you can lose them pretty quickly. And it looks like I've lost a couple. So I'll go back and pick up a few out of our tray. These are sub 1 cent, so I'm not particularly worried about losing a few. But of course, you know, if it was something else, such as a high dollar diode or something, you could get pretty upset about losing that many parts. So grab a soldering iron here, and we're going to put a little bit of solder on the resistor areas that we're going to add. And again, we're going to do the pads we're soldering to on the right hand side, because I'm right-handed with the soldering iron. And same procedure as before. Slide the part in after you heat it. Now again, don't worry about the quality of that solder joint. Now this one, I really didn't slide it far enough over. You really want to give it as much room as possible on the other side. Turn that one over. And then we've got these two down here that we need to add. Here, here. Slide it right into place. So now we got all the resistors in place with one leg. So the last fun part are these wonderful LEDs. These suckers are small. And the biggest problem with these small LEDs is identifying which end is cathode on them. And the problem is with these LEDs, you just can't do it without a magnifying glass or a microscope. So I've got my trusty AM scope microscope that I reviewed before on one of Dave's Dev Lab videos, and I'm just going to look at it under a microscope and make sure that I've got the orientation correct. Yes, definitely want to clean your soldering iron, because dirty soldering iron doesn't work well, especially if you're doing something small this way. I have a nice thing of soldering tip cleaner over here on top of my soldering iron, as well as making sure that the copper cleaning material that's in my base, as well as a wet sponge, to make sure that they're nice and clean when I go through and start soldering each component. So I'm going to pick up one of these parts, and they're just darn small. Have a quick look under the microscope so I can identify which end's the cathode. And there we are. So I need to rotate that way. Put this in place. So just like before, put a little solder on each one of the ends of where I'm going to place these. 1, 2, 3, and then we got 4 and 5. So I'll pick up the one that I've got oriented properly and slide it in place just like the resistors and caps. Now, most of the 0805 LEDs, you can actually see the cathode on it, and most of the time they'll actually mark it with a green bar, but these are just too darn small for them to do that on. Oops. That one's just giving me a little bit of trouble there. So we got those down. We got 2 more here. That one needs to come over some. And one more to go. And that one needs to come over just a little bit. All right, so as we got it right now, we have all of the components tacked down. They're all in place with at least one pad soldered down. So this is where we'll go through and actually use some rosin flux. There's several different ways you can do this. You can use a pin like this one. We also have, you can get it in a syringe. I like to use this for the larger boards that I'm doing, or if they have a lot of pins like a QFP or QFN package that I'm soldering. The other thing is you can just get a standard bottle of flux. Let's see, do I have the bottle handy? Yes, I do. So this is a bottle of rosin flux, and you can get these handy little containers and just use Q-tips to do it. So I keep several different ways to doing that, and there's various types of flux that you can get on thickness and how long it takes to dry out and everything. I do like these little pins because they allow me to get flux right exactly where I want it, and these are very easy to clean. It's very light and easy to clean. So what I'm going to do is put flux on all of the components as they are right now, with just one leg soldered on. And it doesn't take a whole lot to put on there. You just want to look and see that it's wet. And you want to be careful because you remember there's only one leg on some of those devices that's actually soldered down. And this is where we go back and tack down all of those other legs. And so we're going to start out with the resistors and leads. Now once you're done tacking down a few, you can go back and just touch up the other legs of the other ends of those devices. Just make sure those solder joints are cleaned up, because remember when we were first putting them down, we weren't entirely concerned about the quality of the solder joint. We mainly just wanted it to be held in place. Now these components can hold some heat, so you'll notice I'm doing 3 components and then going back and touching the other leg. What happens is you can be it can hold too much heat on that, and it'll actually cause the part to lift up. And that one's just giving me a little trouble there. Put a little extra flux on it. And you can see how those just touching up those pins after putting a little flux on there really improves the overall condition of the solder joint. And so we got these to do. Put extra there. And now I'll touch up the other ends of those. And now the only thing that's left on this is to touch up the other side of the, or add solder to the other ends of these SOT 23 packages. And we'll do that very carefully, because it's 3 pins very close together, And so what happens is, if you're not careful and put too much solder on there, you'll actually end up with a solder bridge between them. So we're going to go back and add those in place. And it looks like we're done. A couple of LEDs aren't very pretty on there, but they should work. We got those in place. Yeah. Let's look here. Looks pretty good. So the next step, I'll step away for just a minute. One of the things that we'll need to do is clean the flux off. We can actually use a flux pen to remove the flux, but I do like to soak this in isopropyl alcohol. For this case, I'm just going to go ahead and use the flux remover and clean it up. Now, one of the things that I do a lot of times when I'm soldering, I have my glasses off so I can see close up. Excuse me. So I've made sure that I've marked the flux remover with green and green on the end, and the actual flux with red and a red cap, so that I can tell which one's which without actually having to put my glasses back on. And there we go. Let's see, make sure we can clean that off just a bit. Whoops. I have a little tub of 99% isopropyl alcohol that I normally clean prototypes with, and then strangely enough, the best thing to clean the isopropyl off afterwards, so that it doesn't leave a residue, is Dial antibacterial foam soap. It works really well for cleanup. So now that we've got the board assembled, we definitely want to do a little bit of testing. One thing that we need to do is add the headers on there. Now, as I was saying, my original thought was to use these headers. Let me switch cameras here so we can see a little bit. These Arduino style headers, and this gives you a little bit more space and extra pins to plug into stuff. So the intention was to set it up like this, with those headers, and then if you wanted to, you could actually use one of the breadboard pins and plug directly into it. Oops, there we go. And that gives you a lot more space to work with. But one of the things I'm not liking about this particular design idea is these stick up pretty far, and it's kind of hard to see these LEDs from an angle. And so I'm not sure that this is going to work out, which one that I might want to do. But for now, I'm going to go ahead and solder this one together for us to test with the additional pins, or the taller headers. So I'm going to pull this out of the board here and put this back in the PCB holder, and I'm going to put it to the edge of the PCB, or the PCB holder, so that I can hold this in place while I tack it down. Alright, got that one tacked down. Yeah. This one in place. Alright, so now that I've got one pin on each header tacked down, I'm going to just go back and finish it up. Alrighty, we've got that added on here. Maybe a bit crooked there. And so we got decision time. And what I've done, I've already got this proto board set up for some testing. Now, a couple notes while I'm getting set up to do some testing here. This parts placement that I've gotten from Eagle, this is your T name layer or B name layer, top, T for top, B for bottom. And you can generate this, and one of the great things about printing directly from Eagle is you can actually scale it up to fit the entire page, and this works really well for a guide. Just turn all the layers off except for T name or T value, and it makes really easy for identifying your parts and where they're going on the design. So I've got this set up to do some testing, but I need some power to this thing. So a while back I bought some of these little modules. These are some really great Chinese modules. They come in various form factor values. This one goes down from 0 to 18 volts, I believe. And I like this one because it gives me a lot of good control for testing, and I'll show you in a minute on that. So I've got a project that I'm planning to do on the video for this, where I build up a nice little case and a system for doing multiple connections and for the desktop power supply. But for now, I went and I had this little plastic box from Office Depot, and I just cut a hole in the top of the box and from the lid, and what I've done is just place the wires through the bottom of the box, and it makes good for just holding it on the desktop. I'm going to feed it 12 volts, and I'm going to hook it into my breadboard that I've got set up, and let's power this on. Now it's really interesting. This has a small MCU on it, and just recently someone posted some open source firmware for this device. It's really impressive. I have the link in the information on the live stream of of the Hackaday article on that. So we've got our power supply, we've got our switches to simulate the input, and we've got our board in place. And now's decision time to see whether this actually works or not. So, or how well my soldering is under pressure here. This is a truth table I've got for a full bit adder for us to test and go through. And we got our red pin, and I don't think I got a green pin and a red pin, but I got a orange Sharpie. That'll be good enough in case we need to mark something that doesn't work. So I'm going to start off excuse me, and enable power at 3 volts. And so we got started here. All our switches are to ground, so all the LEDs are off. The first one is our carry in. When I turn it on, it goes high. The second one is the B, and when I do it, it goes high. And our A, I'm not getting anything. Let's double check. Make sure I got all my stuff in the right place here. And I'm still not getting anything on A. So let me see if it's something on my breadboard that's giving me trouble, or if I got something that's wired incorrectly. Well, it looks like maybe I've got that lead is messed up on there. Let me have a quick look at it on a microscope. Let me see if I soldered it in backwards, which is entirely possible with how small those are. Let's pull the light over here. Quick look. And indeed, I soldered that one in backwards. That's what happens when you try to talk and solder at the same time. So, just need to go back and take A off there, that lead, and replace it. Now, let's put it back on our PCB holder here, make it a little easier to get to. So this brings up a little deal. How's the best way to get one of these little suckers off? Well, the best way to do that is to add a little bit of flux on there. And go through and add a little bit of solder on your tip here, and make sure it bridges across the device. And usually you can get it to come off quite easily. There we go. So I've got that lead off, but our pads aren't going to be too conducive to putting a new lead on there, because both of them have solder on there, and as I said before, we really want to have just one pad soldered with solder on it when we add these in place. So I'm going to use a little solder braid to clean up that one pad and make sure it's nice and flat. And that's what we've got. Whoops. Yep, sorry. Let me switch cams there so you get a better view. So I've got that lead removed. Now I got to put a new one on there. and grab a fresh one. Like I said, these suckers are so small and it's very, very easy to mess up. Let's see here. We want to turn it this way. Try to make it easy to put that in place. Just double check here. And I think I got it right this time. A little light on there. Now this becomes tricky because I got that header in there. Now, don't want to melt the header. And looks like we got it in place. Good to go. Let's get back to debugging. So, a little bit light. All right, so let's kick back on the power, and we've got C, B, and A. So we've got our inputs. So let's look at our truth table. We'll slide this over to the side so we can look at all the ones we want to test. So we want to make sure that when A, B, and C are 0, the sum and the carry out are 0, and that's what we've got right now. We're going to turn on A, and when I turn on A is lit, and B is 0, C is 0, sum is 1, and carry out is 0. So indeed, that's what we've got. Alright, so the next one we want to test is A is 0, B is 1, C is 0, the sum is 1, which it is, and the carry is 0. So the next one we want to test is A and B enabled. A and B. A and B is enabled. Carry is not. Sum is 0, and then our carry is 1, and indeed that's the results. Alright, so we've tested all the A and B combinations with no carry in. So the next step, you can see that we're going to test when we have a carry in. So we've got carry enabled. That means a value coming in from a previous full bit adder. So if you were chaining 4 or 8 of these together, that carry in would come from the 1-bit full adder connected directly to this one, and the carry out would go to the following unit. So when A and B are 0 and carry is 1, we should get a sum of 1 and a carry out of 0. So we're going to enable A. So we've got A is 1, B is 0, C is 1, sum is 0, carry out is 1. So we got 2 more combinations to deal with. So when A is 0, B is 1, carry in is 1, so our output should be sum is 0 and carry out is 1, and it is. So we're looking real good here. And the last combination is when A, B, and C are all 1. We've got our inputs, A, B, and C, and then our sum and carry out is working. So now this circuit is completely working fine as an assembly. So just as a note, I do have one that I assembled earlier, and with just the basic 1/10 inch headers, and I'm going to slide that down. You can see it's a little bit easier to view the pins and LEDs. Actually, let me just plug it in here and we can see the difference in that perspective. Let's see right there. It's a little bit easier to see the labeling and pins and everything. Yeah, I think it's also the camera. Remember, I'm operating at 3 volts, so the camera is not as difficult to pick up. Normally, you would want to use this at 3.3 or 5 volts. Let me see here. I'm going to go ahead and enable that. This is 5 volts, so it's quite much brighter between the 5 volts and 3.3. Yeah, well, I'm not soldering 63 more, but I'll put that on my pick and place machine. So this actual 1-bit adder will be up on 10D here in a week or two. Now that it's working, I'll sell that with the Boolean bits. So I'll just throw that up on the pick and place machine and do a panel of them. But yeah, so part is working well, looks good. I still haven't decided on whether I want to use these stackable headers or just use regular 1/10 inch headers and include them in the box package with the device. So feedback is greatly welcome. I may just include both of them there. It's not a terrible expense. And so this brings me to kind of a what's the word here, sneak peek of what's coming up after the 1-bit full adder. Looking at doing some ALU stuff, arithmetic logic units. And so one of the things I'm prototyping right now is based on the 74 LS 181. The 181 is actually one of the most popular ALU units that's out there over the history of computing, and there's a lot of projects that use it, but sadly it's no longer available new. The only thing you can find right now is new old stock. So what I'm looking at doing is I've got a gate level replica of the 71 181 in an LVC part. Let's see here. So this big board has got all the main components on it for a standard 181. I'm calling it the Mega 181. It's gate level comparison. I mean, it's exact block diagram of what's inside of a 181. And so I'm kind of thinking about selling this. It'd be fairly expensive compared to just buying a new old stock, probably in the $60 to $70 range. But if you're you know, doing a digital logic class and you really want to understand an ALU, this is pretty important. In it'll also have LEDs on all the signals, and I've actually duplicated where the LEDs are from a project Ken Sharif's page that he's got up on details. I've also got that linked in the live stream information, where you can go to his page and look at the design. It's a pretty interesting design. So but yeah, this is going to take me a while to solder all of that together for sure. So that's where we're at. We got our prototype soldered together. It's all working. Looked at some of the tools and stuff that we were used to put everything together, and we tested it. Worked out pretty good with only one lead mistake on the assembly. I'll be happy to answer any questions that you got now, or post on afterwards. I hope you enjoyed the Friday afternoon at Dave's place here. Have a beer and chill, because you know, any self-respecting nerd should be at home on Friday night drinking beer, so playing with electronics. So thanks again for attending.